All right, good morning. I wanted to say thanks to the Tectonic crew for inviting me to come. I've been at Planet Labs for about 2 years now, and we're just kind of getting to the point where we wanted to do a little more discussion and sharing of some of the things that we've been doing, and this was a great opportunity to get out and talk to you today about the transition that we're going through. So one thing is, I am one of those toilers who tends to be in the background running this infrastructure that we've been working through. Because I'm a toiler, I'm a terrible person at naming. So you get this really great, compelling speech title of Managing 6 Petabytes of Earth Imagery with Kubernetes, which I guess is technically accurate, but maybe not that creative. I did try to do a little bit of creative work in thinking about what I was going to talk today, and I thought maybe I'd just share a little bit of some of the alternate title slides for my pitch, just to kind of give you an idea of where I'm coming from. So I thought about this one, which may be accurate as well, but a little less detailed, although maybe not what you think. My cloud problems at Planet come in different forms. One of the biggest ones that maybe you don't run into in what you're doing every day is that people want beautiful pictures of the Earth that look like this. And 60% of the Earth is covered in clouds every day. So the question is, how do you make sure you're getting stuff out to people that don't have clouds in them? And so that's maybe a little different twist on how we think about it. And the reality is, when I finished the presentation and I looked back at it, and I actually thought about what most of you probably want to talk about, this is probably the most accurate title slide that I could have come up with, which is I get to work with space every day, and we're working in space all the time, and oh, by the way, there's some Kubernetes in here. So anyway, it gives you an idea of some of the different range of stuff that maybe I'll talk about, and to kind of dive into that, I thought most of you probably don't know who Planet Labs is, don't know what we do, so I'll give you an idea of kind of what we're doing in the context under which we're running infrastructure, and why it's a big and complicated infrastructure problem, as well as being a very complicated rocket science problem. I'll talk a little bit about how we evolved and our architecture and sort of where we were thinking. I find it sort of interesting that where we started is what a lot of people think of as cloud native. And very sort of forward-thinking. When we started building this thing about 2 or 3 years ago, we thought we were on the bleeding edge of how to build flexible, dynamic, agile infrastructure, and we're already going through a big change. And so I'll kind of talk you through how we started and how we went through that journey, a little bit about why we've landed on Kubernetes as our direction for sort of where that evolution will take us, and maybe try to give you some description about how we're evolving through that process. So Planet's mission, what we wake up and think about every day right now, and we call this our mission one. There's a lot of things you can do with small satellites in space, but our real focus, and this is actually a problem, is we have so many things we could do, it's hard to sort of stay on one thing. So what we've organized the company around is what we call mission one, and this is our mission one, which is we're trying to image the landmass of the Earth every single day. And use that data and cadence in a way that allows people to get things out of Earth imagery that maybe they haven't done before. And not only do we want to image it every day, but we want to provide a platform for people who can easily access that information, and increasingly can access that in a way that actually allows them to get answers about things that are going on versus just data. And I'll sort of walk through what some of those subtleties mean. But I'll give you a couple of examples of some things that people are doing with our data today. So one of the things we've seen people doing is monitoring ports. And in this case, they're not 5-digit numbers. These are actual scenes from Cape Town. And if you walk through a series of imagery that are put together over a few days, you can begin to see the movement of ships coming in and out of the harbor. And people are actually taking these types of images and extending that to watch coastlines and being able to sort of track traffic and where it's going. That can be used for various applications, from economic and financial to more government-oriented applications. But you start to be able to do things by watching change that are very different than if I'm looking at an image a year. Another recent example, this is from June in the San Gabriel Mountains. So this is a picture in early June of that area. One of the fascinating things about imagery, and not having sort of looked at this from a geospatial standpoint, I always think of these things as being very beautiful, sort of inspiring pictures of the Earth that we see. There's actually a lot of analytics that you can do on imagery data that it has nothing to do with visual, but really with just processing the data to learn things from it. So, for instance, this is a vegetation index algorithm that was run that actually detects the density of vegetation based on the colors that are coming back in the imagery. And you can see in this mountain space, we had a lot of density that unfortunately led to the San Gabriel fires. So this is just a couple of weeks later where you can actually start to see where the fires were and even some of the smoke and haze that are left over the area itself. And again, you can run some different analytics on that and the burn scars become very evident. And you can start to track and find out exactly where that vegetation was consumed and how that happened. And so you can extend this to also, using this kind of imagery cadence in natural disaster recoveries, that earthquakes. We've had recent cases where people have found villages in remote areas that were decimated by earthquakes that people didn't even know existed prior to the accident. And so the fact that we can cover the entire world and cover it fairly frequently allows us to do some unique things that we're pretty excited about. So the way the company works to get there is we kind of started with this very agile approach to aerospace and to software. But historically, imagery works by having a couple of large satellites that you spend hundreds of millions of dollars that you launch every 5 years. You task them to go look at things that you think will be interesting. We took a different approach. So we're actually launching a fleet of satellites. We plan to have over 100 of them in orbit that essentially, you can think of them as sort of spinning in a ring around the Earth and creating basically a line scanner of the Earth. So you'll have 100 satellites spinning at a constant angle to the sun. As the Earth rotates underneath, we're taking a picture with each of those satellites every second. We're essentially scanning the Earth, downloading all of those photos to the Earth, and then processing and sort of stitching them together in these sort of big integrated mosaics of the world. And so that's sort of the concept, which was different than this idea of just putting up big satellites and and moving them around and taking pictures of fixed places. We instead, on a 24-hour basis, as the Earth rotates, will then be able to capture everything within that time scale. We've also taken an approach of sort of evolving the satellite itself. So this is actually a picture. We call them the doves. This is the pictures of various builds of our Dove satellites. So we started in 2012. We've actually are on, I think, our 14th or 15th build of the satellite. So we've been building iterations of the satellite. We take the satellite, we put it into space, we take some pictures, we learn about it, we figure out things that work and don't work, we build another version of the satellite, we put it into space. And most of these have been going up on launches to the ISS, and then we push them off the ISS. ISS is a terrible orbit for taking pictures because I can't say it's unpredictable, because everything in space is actually amazingly predictable. We can pinpoint one of these doves' locations just with math, which is amazing. The problem is it's moving in a sort of elliptical around it, so knowing where you're going to be to the sun and getting good pictures. But it was great for testing because there's a lot of rockets that go to the ISS. Unfortunately, a couple of them also didn't make it to the ISS, and we've not only launched 110 satellites, we've lost about 50 in a couple of the accidents that have happened along the way. But the point of this is more to say that we are evolving the satellite, we are evolving our approach, and we have to build a software infrastructure that actually corresponds and deals with this. So in the early days, way back 2 years ago when I started with the company, we had about a dozen satellites at any given time, between 10 and 20 satellites in space. I think we had about 10 ground stations, and we were getting about 10,000 images a day that were sort of flowing through our pipeline. That was something that we could do all of our post-processing with kind of a fleet of about 100 different machines that were sort of running at any given time, maybe 100 to 500 we were spinning up and down depending on the flow of things. And we had an API, a set of services that were really targeted towards our we call our internal data pipeline. And one of the things that we have to do, we talk about a data pipeline. What does that look like for us? Well, we get an image, it comes down to a ground station. Interestingly enough, everything that talks to a satellite for us is regulated. by some various government regulations called EAR and ITAR, but there's some unique things about that, and all of that stuff for us has to run in the AWS GovCloud. Because that has to be in a regulated, secured sort of environment that has certain protections around it, and GovCloud is the only thing that'll work for that. Once we have an image down on Earth, we have more flexibility on what we can do with it. We do all of the post-processing of the images in AWS today. And the post-processing is things like you have 100 different cameras in space. It turns out every different version of the camera is slightly different. So you have to do some things to sort of make up for camera differences, right? So we take baseline pictures, if you will, on Earth before we launch things, and then we know how to sort of map those camera differences to the pictures, so we get some consistency. One of the interesting things we have to do is something called rectification, which is we're taking a 2D picture of the Earth. The Earth is a 3D object, so we essentially have to take this thing from 500 kilometers away and figure out, like, every pixel on the picture has to map to a 3D place on the Earth's surface. And so we're basically doing things. It turns out that we have good telemetry on the satellites, but if you're off by 1/10 of a degree on where you thought you were aiming when you took the picture, you could be off by 100 miles on where the picture is actually taken from. So you have to work through that process. So every image that comes down has to go through this. And so we built this system for doing this internally. And our approach was, we had sort of one service team in the company. We were the SRE team. I guess we were the SRE and the apps team, but we were all sort of together. We had probably 10 developers who were working on infrastructure and the pipeline pieces. Again, as I told you, I'm really awesome at naming. So we had two systems called storage and jobs, and the API. So we had three systems. I work in the plumbing part, and I forget about things like APIs. But these, this was it. We packaged everything up as DEBs as a way to get consistency, because one of the challenges that we do have is that you like to make sure that as an image is touched through all the various processes in the pipeline, we use the same version of software and we have sort of pixel traceability. Like, we need to know that an output image, how we track that back to the direct image that came down from the satellite, and know that we have some consistency there. And so we packaged everything up as DEBs. They went into one single app repository in our environment, and we deployed everything on VMs with Ansible across the environment. So no containerization, but all Ansibleized, all DEBs, all very cloud native, right? We're spinning everything up in AWS on demand. We have lots of flexibility. We use AWS Spot instances to do our sort of bulk processing. And as I said, and everything was kind of tested and deployed as sort of one thing, because we had these dependencies and things that we were removing, and it was all one team, and this was sort of easy to do. So you end up with an environment that looks a bit like this. So we had our API system, our storage system, our job system, our worker instances, everything backed by Postgres. For us, the reason for Postgres is we also have all of this data has geospatial elements, and there's some very good geospatial extensions to Postgres as a data store. And so it works well for the geospatial. It's somewhat limiting for some of the other things that I'll talk about in a minute. But and then we have all of our imagery just sitting in S3. So we essentially, the database, if you will, this storage system keeps all of the metadata that we know about an image. Everything from what satellite it came on to when it came down to Earth to what camera model projections or modifications we've made to things. All that stuff gets stored in the storage database. The image itself is a blob that sits in S3. And so, this was I think, compared to a lot of enterprise environments, we thought we were sort of bleeding edge, and we had a lot of great stuff figured out. And so this is where we've been running for most of the last couple of years. So now we're kind of in this idea. This is where we're going, right? Actually, we're very close to this. The last launches to get us to these numbers are scheduled for January, and I think we're doing pretty well since it's December and I'm allowed out of the office to come talk about this. But so we are going to soon have over 100 satellites. We actually have about 40 in orbit that are actively producing imagery today. So like I said, we're well on this track. We'll have another 60 or more going up in the first quarter of this year, assuming rockets stay on schedule, which is actually even worse than software schedules. But we've upped our ground station count to 26. And I didn't actually mention this, but we build our own ground station network. So we literally have to go buy satellite dishes and put them up and radios that talk But we have upped our communications to be able to get all this imagery downloaded. By June, or more or less, we will be getting over 10 terabytes a day from space, every day, forever. That equates to about 1 million to 1.2 million images per day. And if you want to get an idea of what I have to deal with from a scaling perspective, right now, so as I said, when I got here, we were doing about 10,000 images a day. I would say if I checked this week, we're probably averaging about 350,000 images a day. And by June, I'll be doing about 1.2 million images a day. So that's the kind of workload scale that we're going to be pushing through over the next few months. And this now equates to petabytes of storage. I was actually having a conversation with somebody last week, one of those moments where you say something that you can't even believe that it actually came out of your mouth. But I was talking to somebody about a migration possibility, and I'm like, well, if we're going to move, let's move it now while we only have 6 petabytes of data. And I just was like, did I say that? The other thing is we now have tens of thousands of these virtual machines that have to run consistently to keep the pipeline going. And by the time we get to 1.2 million images a day, we're probably on average running about 30,000 concurrent workloads through the pipeline. And so that number is scaling. And then the last thing is the things we have to do in the system are scaling. So now not only do we have our internal data pipeline, we are opening this up as a public data access program and evolving the number of services. So it turns out, so we have an image that comes down. You've got some people that want an unfettered image because they're using it for analytics. They don't want us to do anything to it. You've got other customers that want an image that looks beautiful. And so we do some color corrections and things. That some people want a mosaic of the best possible pictures over a week or a month's period of time as opposed to the last image that comes out. And you can't generate all of these and just store them. A fully processed, ready-to-consume version of these files is 50 some odd megabytes. So we get a download package from space at 5 megabytes. It blows up to 50 if it's what you want. And if I had to keep like 5 copies of that for everybody forever for 1 billion images over 3 years, you can sort of see that's unsustainable. So we've had to build on-demand systems that fly through and say, oh, you want this format? Give me a couple seconds. I'll go pull the image, generate the format, drop it for you, and you can pull it. But we don't know ahead of time who that's going to be. So it's going to be a very dynamic sort of environment where we don't know enough to sort of say, oh, I need 5 servers for the analytics product and 10 servers for the beautiful image product, and it's all going to be about China tomorrow. So let's focus on that area. I have to kind of be able to do what people ask for when they do it. So it's becoming a much more complicated environment, which I've talked through several of these points already. But the other thing is we're increasing the platform to support different image formats. So while we were off doing these dubs and building that down, we actually acquired another satellite company called Blackbridge, which runs the Rapid Eye satellite constellation. So we're now feeding not only planet images through this, we're feeding Rapid Eye images through this. We're also starting to bring in Landsat data and looking at things like Sentinel-2 and other image sources so that we have an integrated image platform. So it's getting complex on the back end, it's getting big in the middle, and the number of things people want to be able to do with the imagery is expanding. So all that is just sort of a level set of why we are going down this path from something that looked pretty good to something that's more flexible and containerized. Just another example here. This is a sample of, I think, about a month's worth of data, maybe a couple weeks worth of data, but you'll get an idea. So the top line is the graphs from what we call our job system. You'll get an idea of the different kinds of workloads that are coming through, the spikiness of it, our ability to kind of have to spin up resources up and down, through time. And then, the other graph is just our storage, the number of objects and the sort of size of our planet imagery system, which is just the never-ending constant move up and to the right. So that's kind of where we are. And all of these things have sort of evolved to how our teams work, right? So now we have multiple teams. There's not one. We have lots of different services that are operating at very different levels. So our jobs and storage system are fairly mature at this point. They're operating at extremely large scale. We're just kicking off some things to do automated change detection, which is more of an AI-based. So like people don't want every image that comes down. They only want an image that shows something that changed. So how do you start looking at images and detecting change in a meaningful way to people? Very experimental, very early, ties into a lot of different kinds of systems. And so we're balancing out this idea that we have these very emerging sort of experimental efforts where we're trying to understand things with other things that have to run, you know, a million jobs a day, every day, forever, and balancing those out across the infrastructure. We kind of ended up with an unintentional monolith at one point where, you know, we thought we were doing this cool different services things, but by the fact that we were packaging them all together and everybody had to do debs and there was no way to do versioning of things, everybody had to run all the same software, we were basically ending up with a very sort of limiting kind of monolith approach. And the infrastructure for people to be able to engage with became kind of an impediment for us. It actually started to get in the way. The flexibility of cloud wasn't enough flexibility, and everybody started kind of wanting to do their own thing, and we got into a point where this sort of combination of a monolith and the sort of inflexibility of things we were doing were just creating some issues for us. So what are we doing? Well, I mean, you know, it's probably heard this before. It's not new news, but we are moving to containerize our systems. And honestly, that was driven as much by packaging as it was by anything else. But it is the easiest way that we have to really reliably maintain some of the standards that we need to and some of the consistency that we need to, but to give individual teams much more flexibility. And this could be as simple as like, I need to package a new version of SQL Alchemy in my application, or I really want to run this in Go because I can parallelize some of these routines. It becomes much easier to do that in the concept of a container than it is if you have to deb everything and everybody has to use the same dependency chain. It also just gives us much faster and simpler deploys. Most of our deploys today, as I said, are Ansible based on base VMs. So to deploy new nodes or new services, you know, it's crazy, you know, thinking back a few years ago, but the idea that it takes 20 minutes to get a new node up is too long. We need something that'll respond and go faster. And obviously, if you're going to start having tens of thousands of containers, and that looks like your future, you really want something that's going to be able to orchestrate that. And it really seemed pretty obvious to us that Kubernetes was the right approach for all the container orchestration work. It gives us a lot more flexibility from the dynamic allocation standpoint. We can really sort of have this fleet of infrastructure and move these apps around as we need to. If suddenly people are looking at visual images of China, and then all of a sudden, you know, the time shift changes, and it's people wanting to look at analytic products of agricultural fields across Europe. You know, we can sort of move the containers and expand them with the right sets of applications and conversion tools on the fly. We also then can sort of coordinate these services on a much more selective fashion. So as opposed to everything going out at once and being all linked together, you can sort of isolate changes to the areas they need to be as you're evolving these systems. And you know, given that some of these systems will move at a much more rapid pace than others, that becomes instrumental for us. So this is kind of a live snapshot of what our environment looks like today. I'd love to tell you that it was a super simple environment that just was Kubernetes everywhere. But you know, we are in this thing of I get 300,000 images a day, so I can't just stop and move everything to something different. So we've actually taken kind of this phased approach where we are deploying new services and moving some select services over to Kubernetes. So anything that we're doing new today maps into this container-based, pod-based approach to being built and deployed. And that is currently what we call our V1 API, which is really our first API. The V0 API was kind of our experiment, and we realized where we made all of our mistakes. So we're going to, you know, as we're becoming more public and engaging more customers, we're really landing on the V1 API. So all of the V1 API stuff is being done and deployed through Kubernetes. And the combination of, we have some infrastructure services. We have something called Item Store that tracks all of these generated images and what's available for customers, as well as some of the applications around sort of getting mosaics and those pieces. And we've also started on the infrastructure side, beginning to move some of our core services that we expect to last a long time over to Kubernetes. So we have components of our storage system that we're now scaling out through Kubernetes pods, as opposed to the old VM sort of approach. And so this has given us the flexibility of really, you know, starting to introduce that timeline, but we're still able to maintain the existing services that we had prior in kind of the old world, if you will, alongside of them. And so it's been good for us because we feel like we're making progress, we're freeing teams up to go, but we didn't have to come in one day and just kind of go, all right, this is the weekend, we're switching everything over from debs to containers, which I think would have been a little frightening at the scale that we were at. And so just kind of move through that. So we have done some work on some internal tooling. I think the good news is the Kubernetes ecosystem is moving at such a blindingly fast rate. Even some of the stuff we've already spent time on has now moved back into the core of Kubernetes. I think you're seeing the emergence of systems like Tectonic that give you some of these capabilities. But the two areas that we've sort of done our engineering around and we're starting to kind of share more is we kind of think of this as two things. One is a set of tooling really oriented towards our infrastructure team. And so we have the system called Klondike, which is what we use to deploy Kubernetes environments for Planet use, and we're using this both in GovCloud as well as regular AWS. And it just sort of bootstraps the basic environment and does things like ties into our LDAP system, ties in, uses Ansible to vault secrets that we need to do to bootstrap this stuff up. And we're not really intending this to be like a big project that everybody gets behind as the new way to do Kubernetes. We open sourced it mostly to just show an example to people of one way to do things and maybe some learnings along the way that we can share with people. So that's actually on our public GitHub if anybody wants to take a look at that system and just get an idea of what we've done there. The other thing that we've done, some tooling around, we don't, because this is so planet-centric, it's not directly open source available, although I'm happy to talk with people about it. But we've built some things on top of it to just sort of simplify life for the app developers and the teams that are there. So it's really a way in which if you do some specific things in your repo, you can run a set of tools that will kind of automatically generate the environment and the manifests and the service descriptions and the things that you would need to do to sort of prepare that for the pod deployment, so that you eventually can get to the point where you can just point, kubectl create against the repo, and it'll sort of get everything that you want and push this out to our kube cluster. So this is just a way, again, to kind of remove some of the toil from the app teams for us, but give them the flexibility of a pretty wide open environment while we're still trying to sort this stuff out. What we're finding is even a lot of the stuff, like one of the things we have an example of in Klondike is our sort of early attempts at an ingress controller for this is all starting to move back into Kubernetes core. So I think it's great that we may have been a little bit ahead on a few of these things, but we're seeing this stuff move into the ecosystem. And as it does, we hope that we'll be doing less and less of this ourselves and more be able to leverage these sort of existing things that are out there. But outside of that, we've been using the core stuff. We're currently at Kubernetes 1.4, probably moving towards 1.5. And I think at the end of the day, we sort of got what we expected out of this. We found the Kubernetes environment gives us a lot more flexibility and responsiveness. It gives the dev teams more time to dev, but still control over what they're doing and what their services look like, because we didn't really want to be in that environment where you have an ops team that does everything and a dev team. We want them to do both. And this has sort of removed the complexity of the infrastructure so that the devs can still run their service, but focus more on dev and less on systems and servers. I think we've found that this can be a very evolutionary process. Moving to Kubernetes doesn't mean you have to throw everything out and do everything a new way. You can evolve into it, and things can coexist. And we've been able to do, in our own sense, a lot of tooling work that makes this stuff leverageable across teams. So, I don't have my missions team who's doing the GovCloud work building Kubernetes one way, and the pipeline team building it a different way, and the apps team building it a different way. So we've been able to leverage some consistency across that. And look, I think we're just excited about where things are going. I think the evolution of the Kubernetes platform, even just within the last 12 months, when it went from, hey, we should think about this, to, hey, let's start doing it, to now we're ready to go to scale. I think we feel good about our ability to track against that in a way that's not going to be limiting to us. And I think it has set us up as we sort of launch into our real public launch and high-scale operations in 2017. We're well positioned to take advantage of that. So anyway, that's a little bit of what we do. Around if people want to talk a little bit more about this. I think it's pretty interesting work for us to do with the imagery stuff, and I think it's the first time that I've done really exciting leading-edge software infrastructure work where nobody really cares about what I do because everybody else is working on space. But hopefully you found this interesting, and email and Twitter up there if you want to follow up other places. But thanks very much for your time.